Hello, class, and this, I think, is our third lecture in the series. Today we'll be talking about three-dimensional shapes and their properties. The picture in front of you that you see actually displays various three-dimensional shapes, which I hope you are able to see clearly. And so the lecture will hinge on these shapes and their properties. The first thing that we need to look at is probably to try and define the difference between two-dimensional shapes, which are polygons, and three-dimensional shapes, which are polyhedrons. Now, the word dimension really in mathematics means a measurement, which is in the form of a length or a side. So two-dimensional shapes would be regarded to have two sides, which in this case would be a length and a breadth. And three-dimensional shapes would have three dimensions, three lengths, so to speak, or three sides. And the major difference is that three-dimensional shapes actually occupy areal space. Two-dimensional shapes are flat, so they do not occupy the height, the areal space, whereas three-dimensional shapes occupy both the flat space as well as the height, which defines the areal occupation of any space that they occupy. So then, as we discuss three-dimensional shapes, let's now look at their properties. First, probably let me start by talking about the different types of three-dimensional shapes. The different types that we have are cuboids. Then we have cubes. Cubes really is out of the family of cuboids. Then we have prisms, of which cuboids are from the family of prisms. And we have pyramids, cylinders. Cylinders are three-dimensional shapes, as well as spheres. Spheres are also three-dimensional shapes. So these are the different types of three-dimensional shapes that our lecture is going to hinge on. And these are the three-dimensional shapes that you are going to teach really at primary school level. And you'll be amazed that all these shapes really go as far as university mathematics. Their calculations and so on differ, but children's understanding of their properties from elementary school makes them engage with other mathematics affiliations that they are bound to encounter later on in life. So let's start then by looking at the cuboids. So the cuboid we're going to start with is how to really draw a cuboid with the children. Let us say, even in grade 2. So the first thing they have to draw is just a rectangle. Then they need to draw another rectangle on top of that. After they have done that, they then make connections with the vertices, like that. So that's a relatively gentlemanly view of how a cuboid looks like, I think. You will agree with me. Now, let us look at the parts of a cuboid that you will be teaching. Now, it's important to remember that this topic really is a very, very practical topic. So let the children come with their own cuboids. In fact, before you start the lesson, a day before that, ask children to come with the cuboids. Do not even define what a cuboid is. Just tell them, bring me cubes tomorrow. You'll be amazed at the types of teaching aids that they'll bring in front. And also remember that children learn much better from their friends, from the things and the activities that they do. So their own relatives at home, brothers, sisters, and parents, will provide them with these cuboids, and therefore all your illustrations will hinge on what they already have in front of them. So let us look at the cuboid that I have drawn, and in your case, therefore, you'll be asking the children to look at their own cuboids that they have brought in class. So the parts of a cuboid are as follows. The first part that we are going to look at is what is called a vertex or an apex. A vertex really, by definition, it's a vertex. A vertex, by definition, is a point where two or more faces meet. Point where two or more faces meet. So, how many vertices then has a cuboid? So we can count with the children as 1, 2, 3, 4, 5, 6, 7, 8. So a cuboid will have 8 vertices. 8 vertices, and we've defined it as a point where two or more faces. Now we're going to define faces. There is one face, and there is the other face meeting there. So a point where two or more faces meet is regarded as a vertex. The next part of a cuboid is, let's talk about a face. A face of a cuboid is basically a flat surface. Is a flat surface, which is really a polygon. So a face of a cuboid would be that surface, that other surface on the other side. Now, let's move on. I'll draw it again here. So the faces would be seen much better if I opened it up like that. So these would be the various faces of that cuboid. The various faces of that cuboid. And how many would they be? 1, 2, 3, 4, 5, 6 faces, such that if we closed it, it will give us the 6 faces. Now, the faces of a cuboid, therefore, we have said, are flat surfaces. You can see there are flat surfaces which are really polygons, which are, in other words, 2-dimensional. And when put together, they will give us our cuboid. In this case, I think these look like cubes. So they'll probably give us a cuboid like that. But it's important to know, again, to tell the children that these are the faces of the cuboid, and they should be able to point at the various cuboids that they have in front of them and see which ones are the faces as you are explaining to them. They can even begin to number the faces on their own cuboids. That becomes very critical. Their understanding will be much more enhanced when they're actually practically looking at the actual shape and providing the definitions of the various parts of the shape. Then the next part we'll look at of a cuboid is the edge. How many edges has the cuboid? We have established that it has 6 faces. So now, how many edges are the cuboid? The definition of an edge is a line formed by 2 faces. So the edge is the line formed by two faces. So let us look at this face here and that face there. Would see that this face and that face meet at that line there. Therefore, that line would form the edge. It's made up of that face and that face. So, by definition then, a face, rather, not a face, an edge is a line formed by two faces. So an edge is a line formed by two faces. Like we have seen, there is an edge. So all these are various edges. And you would see that at each edge is really formed by, that one is formed by that face, formed by that face. This edge is formed by that face and that face. So all these edges are lines. You can see they are straight lines. Imagine they are straight. They are straight lines that are formed by the faces. So let your children, therefore, with their own cuboids, point at the edges and the faces that form up those various edges. And let them count. Do not provide them the answer yet. They each have their own cuboids. Let them count and arrive at how many edges there are in their cuboids. And if we counted our edges here, I think we'd realize that there is that. So that is 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 edges, 12 edges in a cuboid. There are 12 edges in a cuboid, and an edge is a line formed by two faces. So those are basic definitions, but they ought to know this, because you'll be surprised that, let's redraw that so that I can use it to explain again. You'll be surprised that the children's elementary knowledge of the properties of a cuboid becomes pivotal when in their basic knowledge and also in the knowledge of mathematics thereafter as they advance, because it's these properties that they are still going to use in engineering, in tailoring, in bricklaying, in medicine and so on. They ought to know the properties of the various shapes that they are dealing with. And that knowledge starts from you explaining to them now at elementary level, such that they're able to understand these properties. So we've drawn that and we've provided the definitions. Now let us look at what is, when we open this up, really, or what we have drawn here is really a net of a cuboid. And we can open the net up to give us the faces. Of the cuboid. And one of the questions you may ask the children is, the net is basically also sometimes called a skeleton. It's a skeleton of a cuboid. And they can make these using wires or using strings and so on. And you can make that, and they can display them in class. And so you can give them a project to make a cuboid in various groups, so that you display in class, such that your class becomes very mathematically inclined. When a child walks into class, they're able to see all these shapes, and they're able to relate to their properties. So that's a net of a cuboid, and these are the various faces that it has that you can use, and the faces also made up of the edges. The edges also represent the various vertices that we've talked about. So then, now let's move to prisms and try and define a prism. All prisms are named after their bases. Named after the base. So the prisms are named after the base. And all prisms have two congruent faces. Have two congruent. Not faces, rather, bases. Have two congruent bases. So let me draw one prism. The first prism that I'm going to draw is, we've already, again, done this in the previous slide, is a cube. A cube is a family of prisms where the base is a square. Now, we're talking about the properties of prisms. It's made up of two congruent bases, and in most cases with prisms, other than the special prism, which is the cube, most prisms that are rectangular, the base is rectangular. The base is rectangular. So the base is a rectangular face, and the faces are congruent. The bases are congruent. So you can have two bases. So if I turned it upside down, that would be the base on top. And if the top part came to the bottom, that would be the base. That's why the bases are congruent, and there are two of them. And also rectangular in feature. So that's a rectangular, this would be a rectangular prism. Rectangular prism. Why? Because the base is a rectangle. Then we would have a prism which is a triangle, like that. This would be regarded as a triangular prism because the base is a triangle. Now, going back to the properties, two congruent bases. If we turned it again upside down so that this top part became a base, that top part is congruent to that. So the bases would be congruent, and it has, again, like we've said, this one would be triangular prism because it has a triangular base. So you'd see that the prisms, the names of the prisms are based on the bases that define them. So a rectangular prism has a rectangular base, a triangular prism has a triangular base. Then let's look at a pyramid. A pyramid has one base, has one base, and also triangular faces that meet at the apex or the vertex. It also has triangular faces that meet at the apex or vertex. So these are the two basic properties of a pyramid. One, it would have one base. And again, the names are based on the base, named after the base. So the prism would be named after base. Now let's start with the first one. The first one would probably be, let me draw it and let's see if you can provide the name. So the name of this, which you can see, again, sorry about my drawing really, which leaves much to be desired. There. The base, as we can see, is a rectangle. Therefore, this is a rectangular pyramid. Rectangular pyramid, the reason being the base is a rectangle. Now let us look at another one. We can see that the base is a triangle. The base is a triangle, therefore it is correct for us to say that this would be a triangular pyramid. One, it has one base, which is the triangle. It has triangular faces that meet. It has triangular faces that meet at the apex. That face is a triangle, that face is a triangle, the other face is a triangle, they meet at the apex. When we go back to this one, again, it's the same thing. It is rectangular base, so it's a rectangular pyramid. This is a triangular prism, rather. Triangular prism. Sorry, pyramid. Why am I mentioning a prism? Pyramid, triangular pyramid. It's a triangular pyramid. Again, it falls through the properties, that is triangular base and triangular faces. If we go back to that one, it is a rectangular pyramid, rectangular base, and triangular faces meeting at the apex. So that's how we define really a pyramid, and that's what differentiates it from a prism. Let's probably go to the last one where we draw the two of them. If we draw the two of them, we'd realize that this, and let me complete that. And Let's take, for instance, a triangular pyramid. Now, if we go back to the properties, the prism has the two congruent bases. There is the base, the first base. If we put it upside down, this would be the other base, which would be congruent. And it also has rectangular sides, rectangular faces. The faces are rectangular. So this would be our prism. This would be our prism. And this would be a rectangular prism. And this would be our triangular pyramid. It has one base, which is the triangle. That's why it is a triangular pyramid. The next property is that the triangular faces meet at the apex. The faces are triangular, as we can see. The faces are triangular, and they meet at the apex. Triangular pyramid. Now, the difference, the prism, the top part of the prism is made up of edges, whereas the top part of a triangle, of a pyramid, is an apex. But of course, we can go back to the definitions as well, knowing very well that a prism has two congruent bases and rectangular faces. The faces would be rectangular, whereas a pyramid would have one base, in this case it's triangular, one base, and the faces, no matter what it is, as long as it is a pyramid, the faces will be triangular and meeting at an apex. So that really summarizes our lecture for today. So draw a pyramid and a prism and discuss their differences. Discuss their differences. So, if you are able to do this, if you are able to draw a pyramid, a prism, and discuss their differences, that would be very good. That would summarize what we've talked about today, and also the fact that we've looked at three-dimensional shapes. We've looked at three-dimensional shapes and talked about their properties. We've talked about the vertices. We've talked about the edges, and we've talked about the faces. Vertex, edge, and face. And we have defined also what the faces are, what the edges are, as well as what the vertices are, how you would define mathematically what a vertex is, what an edge is, and what a face of a polyhedron is. And again, remember, these are three-dimensional shapes are polyhedrons, and two-dimensional shapes are polygons. So I think that's the end of today's lecture. I hope you'll be able to explain these concepts easily to your children. I'll meet you again in the next lecture. Goodbye.